We're on.
Is it on? There we go.
Hello. Welcome to Voxon's first ever, the world first, streaming to YouTube of a volumetric display.
Except for your accidental one the other day, Gavin.
Yeah, that's right, Linton. So I'm Gavin Smith, founder of Voxon Photonics, and I've got Linton here as well, and Emmanuel here as well. And yeah, today we're going to hopefully run through a demonstration of our current commercial product, the VX1, the world's most advanced volumetric display. So what we've got here is a studio. We're in Adelaide here inside Australia. We've got a VX1 volumetric display set up here. This is my hand behind it, which hopefully you can see. We've got some nice soft lighting over here, and we've got a camera, Panasonic camera set up at the VX1, and we've also got this webcam pointed at me as well at the same time. So hopefully you can see a little bit of the display and hear me talking as well.
I do have my laptop, so if we have any questions that do come through, I'll try to have a look and work out and let Gavin know what they are. So.
Okay, so let's get started with this demonstration. So what we're looking at here is a volumetric display. Some people call it a hologram, some people call it other things as well, but really what it is a volumetric display, and that means the data that you see, this ant here, exists within a box, and that box is the VX1. So that instead of a resolution like an iPad, where you have an X and a Y resolution, we have an X and a Y and a Z resolution as well. We have got a depth of the box. And just so you understand the shape of this box, I'm just going to take the camera off the tripod and just move it around the box a little bit, just so you can see what happens. If any point we get disconnected, we'll try again in the future. And I'll try and be gentle with the camera so we don't get motion sickness here. So if I just zoom out here, this is the VX1 down here. And as I walk around it, I can't go too far because the cable doesn't stretch, but you can see down here we've got a control screen, and there's Linton on the other side of the VX1. So as I move the camera above the VX1, I may have to adjust the brightness, but you can see the view changes, and you're now looking down on the ant from directly above. And if I go back down again here, you can see I can go all the way down here. I can actually go below this level and see it from below as well. So it's pretty much viewable from any direction. So I'm just going to put the camera back on the tripod over here, and then I'll try and get it to a nice comfortable position. Now over here on the display we have a Space Navigator 3D mouse. This is what we use mostly to interact with the display. And we use these devices because it allows us to move the data in in 6 directions, left, right, up, down, and rotate as well. So if I turn the mouse here, you can see that the ant rotates counterclockwise, and if I go the other way, it goes the other way. On the side of the mouse there's these buttons, and I can use them to zoom in on the ant, and the other button zooms out on the ant. So just before we get into the demo, you're probably saying, how does this thing work? How is this thing 3D? The way it works is we project thousands of slices every second, about 4,000 images every second onto the display. And the screen is physically moving up and down very quickly. If I turn on a single slice by pressing this letter M on the keyboard, I can display a single slice of the ant. So that slice there is 1/4000th of a second. And if I move that up and down, you can see what we see is thousands of cross-sectional images that move up and down. And when we display them all very quickly, we get, through persistence of vision, three-dimensional object that has got the same sort of properties as a real object. Things like motion parallax, depth of focus. If I put the ant like this, for example, and I focus the, I stand on Linton's foot there. If I focus the camera, if I zoom in a little bit and focus the camera, you can actually see I can focus on the front of the ant, on its mandibles, And if I change the focus, I can actually focus on the back of the ant independently. So the ant is physically occupying a space inside the display. So what else can it do? Let's picked up my keyboard here. We support a regular keyboard as well.
Just show on VoxyOS.
And we'll show VoxyOS. So VoxyOS is how we browse through content on the display. The display itself has got a computer inside it. It's got a Windows 10 Intel NUC PC inside it, and any data on that computer can be visible through VoxyOS. So when we're browsing through this menu system here, we're actually looking at folders on the computer. So currently the folder we're in has got a bunch of STL files. I can browse through these and choose one, and when I open it up, it pops up. As long as the file format is recognized, it will pop up in the display. Again, if I pop up this Lamborghini STL file, it will pop up as well. Now we're looking at monochrome just now. We'll look at color a bit later on. You can actually cycle through different monochrome colors through the menu here. That's white, we've got cyan, magenta, green, blue, yellow, and red. And color as well, like I said, I'll show you in a minute. And monochrome is the highest resolution that the display does, and we use that quite a lot. So the detail that you can display is really relevant to how much detail is in the underlying file. This file is fairly low resolution, but if you zoom in on the steering wheel, you'll quickly see that it's a pretty low polygon file. For an example of more resolution, more detail, I'll just jump out to a different folder and go to this one called Scale and show you something that's pretty cool, and that is this model of a fly. So again, this is an STL file, and you may notice on the back of the fly there's another bug sitting on its back. It's tilted over, you can see a little grasshopper on the fly, and if I zoom in on the grasshopper, you'll see that in his back, or her back, there is a cockroach, and on the cockroach's back there's another fly, or a wasp.
It's a very small wasp.
Very small wasp. This is how big wasps are actually in Australia. We'd class this as a very small wasp. Bugs here are pretty big. And then on the head of that wasp there's a dragonfly, and so on, until you get to this level. It starts shaking around a bit because we're getting to the floating point precision of the computer, and it's interesting to compare. If you actually looked at this in real scale, the smallest bug here is 1/1000th of the size of the biggest bug. So the level of detail that you can get really is only down to how much detail is in your actual 3D data set that you're looking at. Let's jump into an animation now.
Yeah, we have to be wary of people nowadays not having very long
Attention spans.
Attention spans is the word.
Yeah. Yeah, that's right, the Instagram generation. So here we have an engine block. This is an animated 3D file. Again, you can see the level of detail inside it. If I zoom in on that, this is an animated STL file sequence. Again, if you take the camera off the tripod, you start to really understand the power of this type of technology for communicating between a group of people, something that's really complicated. Again, if I zoom in really close here, you can focus on different parts of the engine. That'll keep all those people who are into real holography out there, they love to understand things like convergence and accommodation and depth of focus.
The other cool thing is you can have a group of people who can just all gather around and view from all different angles. So this is perfectly suited to collaboration of universities, medical, that sort of thing as well. So.
Put the camera back on the tripod. Okay, what will we show next? Let's jump into some quick example of some fluid dynamics. So this is an animation of a fluid. This is computational fluid dynamics, which was created in Blender, showing an impact of an object crashing into some water or some liquid of some sort. Each one of these images is actually a 3D file. If I pause it, I can rotate it around, I can zoom in and out. each frame is actually a physical three-dimensional object. It's a good time to show some color data. So the VX1 supports color at a slightly less resolution, but we use dithering to create higher sort of range of colors. And I'll just go into this directory here and select a file called Stuart. Now he's not in color yet, but I'm just going to take the camera off the tripod and get Linton to swap it into color mode while I make the camera off the tripod here again. So what we can see here is this file here. We're using dithered color to create a full color palette.
Probably show something a bit brighter in color. This is sort of flash tone, I guess, isn't it?
Flash tone, yeah. You press escape there and just go back into escape on the keyboard. Bring up the DNA or something. There's a scary spider.
Scary spider, I better get out of that one, too scary. That was the...
Butterfly maybe?
Butterfly is probably a good one.
So this is a good example of dithered color. So we only project red, green and blue, but you'll see by using dithering we can create any shade of color. In this case, orange. All right. Back into monochrome, I think now. Okay, let's look at some quick jump into some medical imaging now. I think we'll look at some DICOM data, which is data that comes from a CT scanner. So CT or MRI. CT or MRI scanners create what we call DICOM data, and that is data that's stored in a series of black and white images, and we convert that into a 3D data set in real time. And what that allows us to do is something called segmentation, where we can change the threshold of the data to strip away different parts of the object. So what I'm doing here is changing the threshold of what we're looking at, so getting rid of the skin, which is a very light, very dark color, and revealing just the bone and some other tissue inside. And again, I can rotate this around and zoom inside it at any time. And I can change things like the quality level of the thresholding, so I can really home in on certain parts of the human body. So down at this point now, we can see we're looking at the aorta, which is just off the spine. Maybe zoom out a little bit actually. Yeah. And say we were surgeons and we were interested in doing some surgery on this particular patient, and we wanted to know the thickness of part of the geometry here. What we can do is bring up this little virtual measuring tape. In the middle you can see a little dot, just in the middle about there you can see this little dot, and that's our measuring tape. So what we do is we find where we want to start measuring, and let's just say here, and then we press K, and then we start moving the measuring tape, and just up here you can see it says 5.6 millimeters. So that's the distance, and if I press L at this point I can now measure an angle as well. So that's measuring inside a CT scan of a person, and there's been no post-processing on that. That's a CT scan that's taken directly from the internet. This one was downloaded from the Cancer Imaging Archive website. Some other stuff we can do with DICOM is slicing. And so if I turn on slice mode, what you can see here is a slice through the patient, and by changing the threshold I can get the contrast just right. So as I move the mouse up and down, we're getting a virtual CT scan slice through the patient. And if I zoom out, turn that off again, and zoom right out, let's get the whole body in there. Again, turn it on again, and now you can see we're getting this cross-section of the person, which looks like a traditional grayscale CT scan slice or X-ray image, but normally when you get these types of images they're already on one plane, sagittal or axial, and what we can do is arbitrary slicing on any direction whatsoever. So I'm moving in a random direction. At any point during segmentation, if you've decided you like this particular segmentation here, you can press a button on the screen here and you can save that to an STL file. So if you have a 3D printer or you want to visualize the data in Unity, maybe in VR, you can export that and use it in your own software. So that's DICOM data. What we'll do now is we'll jump out of VoxyOS and we'll show you maybe something.
Maybe a game.
Maybe a game.
Or GraphCalc.
GraphCalc. Okay, so I'm going to shut down the display now, and what you'll see is the display shutting down, and you can see the screen in the VX1 is no longer moving up and down. You can see this piece of glass inside here, which is the volumetric screen. So I'm going to run GraphCalc now. This is a mathematical modeling simulator for displaying math formulas, and you can type your own formulas into the display. I'm going to turn on the screen here the ability to see the graphs. So on the top of the screen you can see it says r equals 5. I don't know if it's clear on the video there, but it says r equals 5. I'm just going to cycle through some of the presets here, and you can see, for example, this formula here is the graph of cosine 7x sine 7y, and that's been generated in real time. And just to prove that, I can type over this formula here, so where it says 2t, for example, at the end, where t is time, if I change that to t, just 1t, then you can see it moves much slower. If I put 23t in there, it moves up and down very quickly. So this is really a way of making maybe mathematics more interesting to learn. We're also at the moment working on a plugin for MATLAB to allow an industry standard piece of software to interface directly with the technology. So I can cycle through other pre-existing graphs on here, and some of them are really quite interesting. That one's quite hypnotic. And this is my personal favorite, which is a graph depicting the ocean and an island, and this is the formula here, which is about 1 page of mathematics, and that was written by a mathematician called Thomas Dabrowski, who lives in the eastern states of America. So that's GraphCalc. Let's jump out of that and look at something else while we're here. Let's try some video gaming. So we're going to run Voxotron, which is a volumetric video game engine written by a company called Lexalawful, who are based in Japan, and they've written this, you call it a fantasy console language that allows you to create games both for Voxotron and Pico 8, which is a 2D version of Voxotron. Pico 8 actually came first, I think, and then Voxotron came along after. So each of these games or cartridges in here is a game that's been written by somebody, and can be up to 4 players. It's a completely destructive sandbox environment, so you can have 4 people all with Xbox controllers all playing against each other. I've got a single Xbox controller plugged in just now, which I'll get Linton to play with. I want to grab that and maybe play some Chaos Fortress.
I'm pretty hopeless at this
Alright,
game.
how about I play it then? And I'm pretty hopeless too, but we'll get the idea. So we might take the camera off in a second. Turn the sound down a bit. So you can see what we've got here. Just while we're in this level here, this strange little dog attacking me. But just to give you an idea of the 3D-ness of this, if I just take the camera off the tripod again, and maybe London can just hold the camera, hand hold it, and give me the keyboard. Get it? So you can really see the 3D aspect of the data here. And as I run around in this level, I've got a little sword at the moment, and if I destroy things, I'm going to cut this little block down here, and you can see it starting to destroy. And if I go around the other side here, it's really 3D. If I go into this level here, I've dropped into a little pool. I think something bad's going to happen here. There's some little octopus monsters.
Yeah, watch out for them.
Trying to catch me. So this game, if I press this start again, I can come back to this explore menu here, and I can choose a different game. For example, the Jelly Room. So in this case, I'm a little green blob bouncing around, and I collect other green blobs. And when I jump on top of this guy here, I get bigger. I gotta get his key, and that opens a door. Ah. Now I gotta get across this laser force field without getting killed by these guys. Let's go to a different one. So there's about 100 of these cartridges on the bulletin board, which is the system that you use to share data. This one is kind of a graphical demonstration of some of the effects you can do. You can also use Lua programming language to write code for this game as well. So you can see this swirling cloud in here. This is all Lua scripting, and same as this lovely hypnotic pattern in here. This is all just a Lua formula. If I go through here, there's a really cool dragon to defeat, which I'm going to try and kill. So, get away from me. So if I pick up this exploding barrel here, how do you pick it up?
You gotta.
No, I'm dead.
Yeah, you've
anyway,
got to get up on the.
Yeah. So that's Voxotron. You can have spend a lot of time in here. You can download the editor for this game on the PC, and you can make your own games, which you can play on the PC or you can play on the VX1. So that's Voxotron. So I think what we're going to do is end this demo by showing you a Unity program. So we have support for Unity, so you can make your own games and applications using Unity. You download our plugin, put it in your Unity environment, and then any data that goes through that box will be rendered on the VX1. You would just copy your application to the display. So this application I'm going to show you, hopefully it'll work, is a gravitational simulation of interplanetary physics. So I'm just going to escape out of our menu here.
Oh, you might as well show you that.
I accidentally came into another demo. Might as well show you this while we're here. So this is a demo. This is a demo of Microsoft's volumetric capture codec. So this was a file that Microsoft sent us, which is a photogrammetry scan from their volumetric capture lab in Los Angeles. And the data is held within a H.264 video codec. So we wrote a plugin to allow you to play this data. This is one example of volumetric capture. We can do it real time using cameras, Kinect, RealSense, Azure, and we can also send the data over a Wi-Fi connection or 5G connection, things like that. So really there's a lot of different things you could do with this technology, and we're kind of this is really an introduction to a few of those things to get people interested and see what they want to look at next. So I'll drop out of this demo now. And I'll just navigate to the right folder. Give me 1 second. So this demo here is, as I mentioned before, it's an interplanetary gravity simulation program. I'm just going to put the camera back on the tripod. So I'm going to just put the camera here. I'm going to lower it down a little bit just so you get a different view for it. And tilt it a little bit. And what you can see in here is a planet. And that planet, it was a sphere which I created within Unity. And as I make it bigger, you can see I've also created 1,000 asteroids. Actually, I'm going to change the aspect ratio to make it a bit more spherical. Here we go. So I've created this sphere. And yeah, as I said, all these little asteroids. So what I'm going to do now is change the gravitational pull of the planet, and we're going to see how the little asteroids are affected. So when I press the left mouse button on the planet, on the space mouse, the planet gets bigger, and when I press the right button, it gets smaller. And as it grows and shrinks, the associated gravitational pull of that planet changes as well, and the physical attraction of the little asteroids start coming in. But what's really cool is when I start moving the mouse around, and you get these asteroids starting to chase the planet. And so I've left them to go off a bit, and now if I increase the size, you'll see them start to come in and start to orbit the planet. But the orbits are all relative to the size and the mass of the individual objects. So now what we're seeing is a kind of Saturn-like planet start to evolve, and this is all happening in real time, based purely on mathematics, on physics. And I'm not touching the simulation anymore. I'm just letting it run at the moment. If I move the planet down the way, you'll see that the asteroids start to descend. If I move it back up again, they'll start to come back up again. If I make it really big, they'll all come flying in and crash because the gravitation has suddenly gone back up again. So how we're going to finish this video is I'm just going to start these shuffling around, and then we're going to leave it for 20 minutes, and we're going to come back and we're going to see how this planet looks like, if it settles into a nice pleasant looking Saturn, or if all the particles end up floating in outer space. So I'm just going to mix it up a little bit here and get this planetary system started. So we hope you've enjoyed this first introduction of a live streaming of volumetric data. We plan to have more of these in the future. Please leave some comments, please subscribe. You can follow us on Twitter and LinkedIn, and send us your ideas, and we'll try and display some of them on the VX1 in the coming weeks.
And Gavin, one of the questions was, is this just a project or is it commercially available? And,
I should look at the camera for a second, and I forget I'm on camera here. So the VX1 is a commercial product. We make them here in South Australia. They're $9,800. So they're not consumer yet, but they're certainly within the price range of schools and universities, and those are the kind of places which we're currently targeting. Ultimately, in the future, we want to make consumer devices and bring the cost down. For now, they're an expensive item, but they're certainly unique, and we think you'll have a lot of interest in using them. We've already got many people around the world experimenting with these devices. They're being used in Harvard and MIT, Carnegie Mellon, University of Mississippi and Antwerp University. And they're all using them for different things. Some people for volumetric dance and simulation, for motion capture, for design, gaming, UX and UI. Really too many different use cases to talk about just now. If you want more information, then go to our website at www.voxon.co. And you'll see a bunch of information in there. We've also got a news blog on there, a news page on there. And
check out the news page. So it's just /news, and that's got a whole heap of different demos and things. Gavin tends to like doing lots of different crazy experiments. So that's always interesting.
If you want to make some content for us to demonstrate and show next time, what we'll do is if you email us a link to a file that we can download. We support Blender. If you want to make a Blender file or an OBJ or an STL file or an FBX file,
or a Unity project,
we can get them running and show you what it looks like. But for now, we'll leave you with this gravitational simulation. We'll leave it running for a bit, and we'll see you next time.
And I'll answer any questions that come through in the next 10 minutes or so as well. Okay. So.
Yeah. Bye for now. We're going to leave this going, and
we're just going to live.
Go get a cup of coffee. just come back in to shake my planet up a little.